Okay, so I'm going to solve this problem, rate in, rate out mixture problem. Here's the diagram, and I put the salt shaker there not because there's like separately salt is not added to anything, but I just wanted to highlight because it looks like pure water that it's not pure water. Whatever is being dumped into the tank is salty liquid, and we're not told that it's water. It says contain 200 liters of fluid in which 30 grams of salt is dissolved. So this bucket that's being dumped is salty, and then this liquid that's already in the tank also includes salt in it, 30 grams. And obviously the outflow is going to be salty naturally.
See that drop? That's a little salty.
So then there are these quantities that I highlighted. The first quantity that's highlighted, 30 grams, is going to come into play later. That's going to help us calculate the constant of integration. And green, whatever is highlighted in green, is the concentration of salt. So grams of salt per solution. That's being dumped in. In the first case, 1 gram of salt per liter is pumped into the tank. So this bucket, this violet purple bucket that's being dumped, it has 1 gram of salt per liter. So it gave you a ratio. And you need to find the concentration of salt in the tank at time t, which is always changing because things are added and things are leaving the tank. So most importantly, I just wanted to show that when you stack rate in and rate out on top of each other, you see that there are two ratios that are multiplied together. First is concentration of salt, and second is the rate of salt. And obviously, in rate in, the concentration of salt is going to be referring to the concentration of salt in inflow, so bucket coming in. And in rate out, the concentration of salt in outflow, right? So that makes sense. You would never, and they're multiplied by respective rates. You would never put output rate of brine in the rate in equation, hopefully. So here, again, these green ratios are concentrations of salt, so grams of salt, and then liters get canceled, and you're left with grams per minute, exactly what you're after, concentration of salt in time t as a function of t. So then there is this differential equation, which I'm going to continue, or I'm going to solve in my iPad, because there's a little technique there that I want to show. Okay, so here is this problem. As we discussed, this is concentration of inflow, concentration of outflow times input rate of brine, output rate of brine. Ta-da! So here is where we left off, and I'm just gonna move this over here, and with the plus sign, obviously. 4 is left here, so this is 1 over 50. That's pt, or if you px is 1 over 50, and then mu is e integral of px dx. That's exactly what I'm doing here. Then, I don't want to show you too much. Don't get overwhelmed. I'll explain every line. So here is basically mu times y, and then equals to, usually it's 0 times y, but or most of the time, so far it's been 0 times mu, but that's what's happening here. This is mu, and this is mu, and this is the function y, or at here. So then you put integral here and dt, and then these get canceled, and then integral here and dt, and you take this integral, and this right here is a, so it's gonna be, so it's ax is gonna be ax over a, right? So it's E150t over 150, which is 50e. So there. Now, this is a trick. So you have to multiply everything by e to the negative 150. so that you are left with e to 0, which is 1. So here, everything, right? So you have to put e to the negative 150 times t, and then with c as well. So all of these are going to be e0. This is going to be e0. So here, which is 1, and then there. That's what you're left with. Now, the final step is to find c, and that's where the initial condition comes in. At initial time equals 0, amount of salt in this liquid was 30 grams. So A, as t equals 0, is 30. It's also this function. And when t equals 0, it's, you put 0 here, and that's going to be E0, which is 1. So you're left with 30 equals 200 plus c. c is negative 170. And you just rewrite that for more general. When t is whatever t, you rewrite it like so. But I thought that multiplying at this point right here, multiplying everything by this was pretty clever.